Hello and welcome to topic 2. We will see what equipment and tools you might use to create augmented reality experiences for STEM education. Augmented reality equipment usually looks very futuristic, but while the performance of augmented reality technology has increased steadily over time, the truth is that the main components of the hardware have stayed the same. We have sensors, processors, and displays. Let's talk briefly about each of them. The role of the sensors is to provide information for tracking and registration. This is mainly achieved through an optical camera, usually with the help of sensors such as GPS, accelerometers, and gyroscopes. The next important component, processors. They have the task of getting this information from the sensors, processing it according to the case scenario, and sending appropriate data to the display. Processors may be composed of CPUs for processing data, sometimes accompanied by GPUs for processing graphics. Finally, displays. These are the most prominent part of the hardware and it seems the most impactful for the end user. Displays are usually visual ones in the form of head-mounted displays that we wear on our head, handheld displays that we keep in our hand, or spatial augmented reality displays that work somewhere in the space around us. But we can also encounter less common forms of displays, such as tactile, audio, or olfactory. Let's see some examples of head-mounted displays, the augmented reality glasses. They consist of a pair of glasses that use transparent or semi-transparent displays to project virtual images, videos, or animations onto the user's field of view. They have sensors that are built in to track the user's movements and location, but they may be connected to a mobile device that provides the necessary computational power. Take a look at the Vuzix M4000 in the photo. They can provide contextually relevant information, and you can use them for interactive experiences and enhanced visualizations, like, for example, step-by-step instructions overlaid on a real-world object. Another example of head-mounted displays are the mixed reality glasses. These are wearable devices that combine both augmented reality and virtual reality technologies, but we are talking about them here because they are closer to the augmented reality ones. These glasses perform real-time spatial mapping and understanding of the surroundings, thus creating the perception that the digital content is anchored to the user's environment. Users can physically interact with the virtual objects by manipulating them. Take a look at the Microsoft HoloLens 2 in the photo. These glasses are used for realistic training simulations, architectural and design visualization, and remote collaboration. Let's see exactly how these mixed reality glasses work. In this video, you will see an application for Microsoft HoloLens 2 developed by an international team of students at the initiative of the Polytechnica University of Timișoara within the project Spotlight Heritage Timișoara for Timișoara 2023 European Capital of Culture. The students created together a digital story in mixed reality with the resources of the Spotlight Heritage Timișoara project, using artifacts, text, and multimedia stories and integrating them into a mixed reality experience. This project, called Timișoara Quest in XR, is a virtual environment in which users can interact and learn more about certain artifacts from the heritage of the National Museum of Banat. As you can see, All the content of the application is superimposed on reality, and users can also see the real environment around them. The mixed reality glasses allow them to interact with the artifacts inside the boxes that are scattered all over the real environment, and to discover and learn some more information about these artifacts. The other big category of augmented reality equipment consists of smartphones and tablets. Nowadays, due to their ubiquity and versatility, smartphones have become the main vehicle for augmented reality experiences in many fields, including education. Their integrated hardware, display, sensors, camera, processor, all in one device, combined with vast application ecosystems and powerful software development kits and frameworks, make smartphones a great choice for teaching with augmented reality. Let me remind you of the Spotlight Timișoara augmented reality application, which was also showcased in topic 1. The application allows users to point the smartphone towards a landmark, recognizes the building, shows how the building looked like in the past, and gives the user some more information about it. The application is available virtually to anyone in the world with a smartphone, either Android or iOS. So, it seems that both smartphones and augmented reality glasses have their strengths and trade-offs when it comes to delivering augmented reality experiences for education. On one hand, smartphones are widely accessible, versatile, and already integrated into users' daily lives. On the other hand, augmented reality glasses are more immersive, are hands-free experience with a wider field of view, and have enhanced interaction methods. But they are still evolving and may have limitations in terms of app availability and cost, some of them being in the range of thousands of dollars. Congratulations! Now you know what hardware you can use to run and create augmented reality experiences. Next, we'll talk about software tools for creating augmented reality experiences for STEM education.